collagenous fibers, elastic fibers, and reticular fibers. The two that you guys are going to be able to see are the collagen and the elastic fibers. The reticular fibers, you need to have a specific stain in order to see the reticular fibers. So just know that with certain types of tissues they're there, but you're not going to be able to see them because of the preparation of that particular slide. But the two that you will be able to see are the collagen and the elastic. Okay? Those are the two big ones that you'll be able to see on there. So embedded in that ground substance will not only be the fibers, okay, but you also find certain types of cells. The cells, based upon the type of tissue that we're in, whether it's loose, dense, or vascular, they can be, the ground substance can be liquid. So like in the case of the plasma portion of the blood, that's liquid. A jelly-like substance, like with cartilage, okay, and then solid bone. All right, so that's that ground substance that base is going to contain cells and fibers. Right? Now, prefixes, right? Fibro refers to fiber, chondro refers to cartilage, and osteo refers to bone. So fibro, fibers, right? Chondro, cartilage, and osteo for bone. And then we'll add these prefixes to things like blast, class, and site. A blast, so a fibroblast, will build fibers. A fibroclast will be responsible for breaking down fibers. Okay? So as you age, right, part of the reason why you need to get, those collagen injections is because the fibroblasts aren't building fibers as fast as the fibroclasts are breaking them down. That's part of the reason why. Right? And then you got to go and get your, your cho-cho lips redone. Right? All right? For those of you guys that have been to Hawaii, you guys definitely know what cho-cho lips are. All right? And then the sites are typically the mature ones. Okay? And with some of these cells, what you'll find is that, like with bone and cartilage, they have a tendency to wall themselves in, especially with bone. Bone has a tendency to wall themselves in. All right? So we're going to look at fibers. We're going to look at different types of cells. They're going to be embedded into the ground substance. Right? This ground substance is sometimes referred to as the matrix. All right? And that matrix can be liquid, jelly-like, or solid. So solid, think bone. Jelly-like, think cartilage. Right? Liquid, think the plasma portion and the blood. So the first type that we're going to take a look at are loose connective tissue. Right? And one of the first loose connective tissue that you're going to look at is areolar connective tissue. Areolar is spelled A-R-E-O-L-A-R. Out of all of the connective tissues, this one does not have a really specific role. Right? This areolar connective tissue is essentially the packing material for your body. Right? And so basically, one of the things, like part of the reason why your organs don't move around is because they're anchored. Right? They're anchored by this areolar connective tissue on there. Alright, so in areolar connective tissue, see those what look like nuclei in there? These are the fibroblasts. Right. Some of these larger cells that you're looking at are probably macrophages, right? Because we're not staining specifically for them. Right? So this large one. So now, on a lab practical, I will give you a clue as to what I want you to write down for this particular cell. So for example, question would be, name the cell at the tip of the pointer. Right? This one's responsible for producing something. Your answer in this case would be fibroblast. All right? Or if the question was, name the cell at the tip of the pointer, here's a mature one. Your answer would be fibrocyte. Right? If it's responsible for breakdown, then you would write fibroblasts. Does that make sense to everybody? All right, so I will give you a hint as to what answer I want you to record for this. Right. Now, the fibers that you see these dark fibers right here? Right. That dark fiber right there is elastic fiber. The protein in there is elastin. Right? Stretchy, stretch it out, it's going to give a rebound. All right. The collagenous fibers are these darker, thicker purple ones. All right. So see these thicker purple ones right here that are kind of wavy. So all the those that are coming in focus, those are the elastic fibers. But it's this one right there at the tip of the pointer. See how it looks a little wavy on there? Right, you can see these right here that look a little wavy right here. Those are the collagenous fibers, okay? Right. Does have a little give, but it's more resilient. So what helps to anchor your skin to your body is this arular connective tissue. Right? What keeps your organs in place, right, is this arular connective tissue on there. All right. Everybody feel pretty comfortable with the arular connective tissue? Another one of the soft or loose connective tissues that we're going to take a look at is adipose tissue. And here you can see the adipose tissue around this vessel right here. What kind of vessel is this right here that we're looking at? It's an artery. How can you tell? Tunica media is bigger, right? But also, if you look at the right here, here you can actually see the inner elastic membrane. See that dark structure right there? There's the inner elastic membrane right there, right? But here's the smooth muscle right there, and then here's the connective tissue there on the outside. See this layer out here? Here's the adipose tissue right here. Let's back this out a little bit. There's a lot right there, right? Adipose tissue. That's connective tissue, right? Alright, so if you look at adipose tissue, alright, you can see the nucleus is pushed off to the side. There are elastic fibers here. There are no collagenous fibers around here. And the adipose tissue, one of the big things is that it is going, when you fill these suckers up, right, energy storage, right, insulation, cushioning. So remember back to your basic, your bio 3A or your general bio course, where you talked about, adipose, fat, right? What are some of the functions of fat? Right? So this is what we refer to as white adipose tissue, because there's a difference when we start talking about brown adipose tissue. Right? When we get to chapter 40, we're going to talk briefly about some of the chapter 40 stuff in the next day or two. And when we get to that particular chapter, we're going to talk about brown adipose tissue, on how brown adipose tissue, it has a greater amount of mitochondria, and it's basically involved with a thermogenic capacity. Right? This white adipose tissue right here is primarily for energy storage, right? For insulation, for cushioning and protecting organs, okay? Warmth, okay? All right. So when we start doing some of the dissections, you'll find a lot of this white adipose tissue
around the kidneys, around the heart, right? Behind the back of the eyeball. So when we dissect the sheep eye, right? When you guys dissect the sheep eye, you'll be able to see all those different things on there. All right. Everybody feel pretty comfortable with this? All right. And then for us, this would be your saddlebags or your love handles. All right. It's another wonderful spot to find adipose tissue. Alright, so those are the two loose ones, okay? Now, blood is also derived from loose connective tissue. Alright? And if you take a look at, I'll go ahead and just skip over to, I'll follow along what's in the lab first. Alright? So, keep in mind that blood is derived from loose connective tissue. But I'm going to take a look at dense connective tissue first. All right. Dense connective tissue is dense because of the arrangement of the substances in that matrix. The first one is dense white fibrous connective tissue. When you take a look at the slide, there are two. Basically, on each slide you'll see a longitudinal section and a cross section on this. This one that you're looking at right here is the longitudinal section. And what you're looking at are the wavy lines. So I'm going to turn I turn the light source down a little bit so you can see how the lines are pretty darn wavy on there. That is the collagen fibers. So think tendons and ligaments. Right. This is that dense white fibrous connective tissue on there. The cells that you see right here, fibroblasts. So here are the fibroblasts on there. Fibers. And then when you take a look at them at cross section, you can see the fibroblasts, right, in between the fibers. Okay, so here's the cross section of which. So, now what we're going to switch over to is we're going to take a look at bone. With bone is also one of these, this is the most dense out of all the connective tissues. And so when you take a look at this, right, you notice how there's a bunch of concentric rings on here. So you see this really dark portion here, here. This one's kind of more open on this one right here. That's the central portion of each of what's referred to as an osteon, right? So the osteon. So when you look at bone, this is a cross section. So for example, so if we take this bone right here, right, here's the marrow. This is the marrow. Right, this is what's referred to as compact bone. What we're looking at is you're looking at a cross section right through here. This is what the slide is of the compact bone right through there. All right. So instead of looking at a peripheral view, you're looking at it at this angle right here. So instead of looking at straight up and down, you're looking at it straight on. from the top. So somebody just took a cut right through there, and you're looking straight down at that bone right there. Okay? So you can see how there's concentric rings over here on each one of these. Okay? So each one of these circles represents what's called an osteon. Right? You may come across the term Haversian, right? A Haversian canal. So the very center portion, that's the osteon canal. So if we look at this, so this whole thing, whole structure is the osteon. That's the osteon canal. All right. Each layer is referred to as a lamellae. And one of the things that you notice how there's a bunch of these little dark spots everywhere in the rings? So you see this portion right here, all right? Inside this area, all right, this is called a lacunae. Within the lacunae, you will find the osteoblast. Lacunae is just an opening, okay? Lacunae is just an opening, all right? So this is an opening right there. But within the lacunae, you're going to find the osteoblast. And with the osteoblast, what they basically do is they produce that bone material. Right? So in this bone material, they're going to put down, you know, the phosphates and so forth and make it nice and dense. Okay. So basically, what happens here with this osteoblast is they start to wall themselves in. And once they wall themselves in, they go from osteoblast to osteocytes, because now you're walled in, you're stuck. It's like you've seen the classic, you know, do-it-yourself videos, or you know, on TV you always hear about somebody's they're waxing the floor, right? They start from the door, next thing you know they wax themselves, or they painted themselves into the corner. That's kind of the same idea with bone, is they kind of start building and then they wall themselves in. Now they're kind of stuck. That makes sense to everybody? All right. So that's the osteoblast. They're located in the lacunae. And what you're looking at right here are the lacunae. All right? Now the question comes is, you got to get nutrients out there, right? The nutrients, the arteries, the veins, right? The blood supply is here in the osteon canal. How are you going to get it all the way out here to the lacunae, right? All right? So if you look, one of the things that you'll see is there's a little, like, what look like a little tributary system that kind of comes up. These guys canaliculi is what they're called. Right? So it's like you know, like the Italian cannoli thing. I know it doesn't show it very well up here, but when you look at it on the scope and you turn down the light a little bit, what you'll see coming out from the osteon canal are these little, oh, you can kind of see some over here, right? Coming out, and they'll go to where the lacunae are. All right? So you can see how the bone, the osteon, right? Notice how they're produced like rings in a tree. But there's lots of these guys. Alright. So this is kind of the nice thing about having that living endoskeleton, is if you break this, right, what will it do? It'll repair itself, right? And then because it grows with you, right, you can get quite large in size. Let me find some. You can see a little bit. There's one right here, right, that you can actually see. Right, you guys see that little thin thread? That's a canaliculi. All right. There was something back here that I wanted to show you. Now, all of these osteon canals are interconnected with each other. So you can think of these, there are a bunch of these parallel canals running the length of your compact bone. Right? So these osteon canals are connected. This one is not going to be, this one just happens to be more clear looking. So you notice how, if we look right here, see this big long thing that kind of snakes through? Right through here, connecting several osteon canals together. Right? That is called Volkmann's canal. So Volkmann's connects those osteon canals together. And sometimes when you find a good bone slide, it'll be nice and dark for you. Right? This one just happens to be kind of clear, but you can see, look at all, there's 1, 2, 3, 4, 5, there's like 6 osteon canals that you can actually see in that view, right, where it's connected. You can see how this osteon canal is kind of smeared out a little bit, and this one is also, right? Those are going to be interconnected as well. And you can see how these two are almost connected together, right? Just depends upon where that bone got sliced for you. You can see how that one's connected.
So is there always a Volkmann's canal, or is it just sometimes?
They're all, well, it just depends upon the slice.
No.
Right? If you get it just right, then you'll find it. If not, you're not going to see it.
So you can't always see it, but there always is one there.
There's a bunch of them. Here's a Volkmann's right down here. Right? So you can see Volkmann's. It basically runs right down through there. So now on this guy, here's your canaliculi. So you can see these ones a lot better. Right, there's the canaliculi right there. So that's how the blood vessels, that's how the blood supply, the nutrients, get out to the bone cells. So for those of you guys who've had anatomy already, right, this should all be familiar stuff. Correct? Alright, that's bone. Now the next two are, that's part of the dense connective tissue, is cartilage. And with cartilage, we have two types of cartilage here that we're going to take a look at. Name the tissue type at the tip of the pointer. What's the function?
Installation, protection.
Sure.
Energy stores.
Cushion.
So adipose is just another word for fat? Or are they different things?
Yeah. They're fat cells. basically. Adipose is the scientific term. Fat is your layman's term. Name the structure right here at the tip of the pointer. Make it bigger. Nucleus, you got it. Okay. So what you're looking at basically is the large vacuole that's in there. Alright, so there we go. So now the term that you guys are going to use here is chondro. Okay. Chondroblasts, chondrocytes, chondroclast. Alright, so this is hyaline cartilage. Let's show you this first. So here is a view of the cartilage. So the cartilage is right there where the pointer is. Notice how it's surrounded by a lot of that adipose tissue in there. Right. Within this jelly-like matrix right here, what you have are both collagenous and elastic fibers here. Alright, so just know that they're there. You're not going to be able to see them. When we look at the elastic fibers, you'll be able to see elastic cartilage. You'll actually be able to see elastic fibers on those. Alright, so with cartilage has a tendency to grow from inside out. So in the middle, see how the lacunae, so here's that term again, right? Lacunae, you can actually see the lacunae is really large in this cell right here. Here is a chondroblast. Okay. So all the cells in the center are chondroblasts. When you get out here towards the edge, here are the chondrocytes. So cartilage grows from the inside towards the outside. When you get to the outside, those are the chondrocytes, and the inside, these are the chondroblasts. Right. So this is probably the most abundant type of cartilage that we have throughout. Okay. When you're eating that hunk of meat, that gristle, that's part of that gristle right here. All right. But think of the end of your nose, that cartilage that's at the tip of your nose right there. That's this one right here. Okay. All right. This is also that same cartilage that your bone that's